Assalamu alaikum. Now we will study the chemical properties of alkenes. Alkenes are more reactive than alkanes due to the presence of pi electrons. They undergo electrophilic addition reaction. We will study the reactions one by one. First is the hydrogenation of alkenes. Catalytic hydrogenation of alkenes forms alkanes. That is, if you carry out the hydrogenation of ethene, it forms ethane in presence of a catalyst, that is either platinum, palladium, nickel at high temperature. Propene forms propane as a result of catalytic hydrogenation. Now let's see the next reaction, that is halogenation. Alkenes are converted to vicinal dihalides by addition of halogens. First we will see the reaction with chlorine. So ethene adds chlorine to form 1,2-dichloroethane, which is a vicinal dihalide. Propene adds bromine to form 1,2-dibromopropane. The reddish brown color of bromine disappears in CCl4 solution. So if a carbon-carbon double bond is present in the given compound, this test is carried out. It is a test for unsaturation. Next, that is the iodine. Iodine generally fails to react. Let us see the addition of hydrogen halides, which is the third reaction. It is also called as hydrohalogenation. Alkenes react with hydrogen halides, HCl, HBr, Hi, and get converted into the corresponding alkyl halides. The order of reactivity is Hi is greater than HBr and HBr it is greater than HCl. And let us see the addition of HBr to symmetrical alkenes. There are two types of alkenes, one is symmetrical and the other is unsymmetrical. If to the left and right side of the double bond there are equal number of carbon atoms, then it is called as the symmetrical alkene. If to the left side and right side of the double bond there are unequal number of carbon atoms, it is called as the unsymmetrical alkene. First we will study about the addition of HBr to symmetrical alkenes. Alkenes add on the HBr to form alkyl halide. Ethene forms bromoethane. And addition of HBr to unsymmetrical alkene, it takes place according to the Markovnikov's rule. Let us see what is Markovnikov's rule. Whenever an unsymmetrical reagent, that is HBr, adds to unsymmetrical alkene, that is propene, then the negative part of the adding agent, that is Br minus, it will get attached to that carbon atom of the alkene which has the lowest number of hydrogen atoms. Therefore, according to Markovnikov's rule, 2-bromopropane is the major product. But if we carry out the reaction, same reaction in presence of benzoyl peroxide, then 1-bromopropane is formed as the major product, which is also called as the anti-Markovnikov's rule, peroxide effect or Kharash-Mayo effect. Let us see about the addition of sulfuric acid to alkenes. Alkenes react with cold and concentrated sulfuric acid to form alkyl hydrogen sulfate. But this alkyl hydrogen sulfate, it again reacts with water and alcohol is formed. So first alkene, let us take the example ethene, it reacts with sulfuric acid to form ethyl hydrogen sulfate. Then this ethyl hydrogen sulfate, it reacts with water to form alcohol, that is ethanol. Next example is of propene. Propene reacts with sulfuric acid to form isopropyl hydrogen sulfate, and this isopropyl hydrogen sulfate, it is diluted with water to give propane to all. Next reaction, that is the ozonalysis of alkenes. When ozone gas is passed into the solution of alkenes in CCl4, it forms unstable alkene ozonide. This ozonide is treated with water in presence of zinc dust to form either aldehydes or ketones, or both may be formed. Zinc dust actually prevents the formation of H2O2, which oxidizes aldehydes to acids. And this reaction is used to locate the position and determine the number of double bonds in alkenes. Now let us see this example, that is ethene. It adds on this ozone in presence of CCl4 to form ethene ozonide. This double bond breaks, there is one O which is added to the upper side and two oxygens on the lower side. This is the structure of ethene ozonide. This ethene ozonide, it reacts with zinc dust to form formaldehyde and zinc oxide. Another example is of propene. It adds on ozone to form propene ozonide, which on further reaction with zinc dust gives acetaldehyde and formaldehyde. That two types of aldehydes are formed. Next reaction is the hydroboration reaction, that is the oxidation of alkenes. Alkenes react with diborane in tetrahydrofuran and undergoes hydroboration to form trialkylborane. And this trialkylborane on oxidation with alkaline peroxide forms primary alcohol. In unsymmetrical alkenes, the reaction is given according to the anti-Markovnikov's product. Now let us see this example. This is ethene. It adds on this diborane to form triethylborane. That is, ethene reacts with diborane to form triethylborane, and this triethylborane on oxidation with alkaline peroxide, hydrogen peroxide, it forms ethanol. Similarly, propene forms tri and propylborane, which on further oxidation with alkaline peroxide forms propane 1-ol. That means alkenes forms alcohols in this way. Now let us see the next reaction, which is polymerization. The process in which a large number of small molecules or the single units, which are called as monomers, they combine together to form a long chain molecule. This process is called as the polymerization process. A polymer consists of large number of repeated units of monomers. For example, ethene forms polyethene. Now let us see the next reaction, which is the hydroxylation. Alkenes react with cold and dilute alkaline KMnO4 to form glycols. Let us see this ethene. It forms ethane 1,2-diol, that is glycol. Such reactions are used for detecting the presence of double bond in the given compound, because in this reaction the purple color of the KMnO4 disappears. This is known as the Bayer's test. Now next reaction is oxidation. Alkenes on oxidation with acidic KMnO4 or potassium dichromate, they form ketones or acids. Let us see the example. Propene, it forms ethanoic acid, and 2-methyl-butene on oxidation, it forms propan 2-one and ethanoic acid. Now this is all about the reactions and chemical properties of alkenes. Now let us proceed to the uses of alkenes. Alkenes are used to prepare alkyl halides, alcohols, aldehydes, ketones, acids, etc. Ethene is also used in the preparation of polyethene and propene for polypropene. Ethene is used for the artificial ripening of fruits like mangoes.